Good morning, good afternoon, good evening. Hope you are all well. So today we are going to discuss the second problem in the TLE Eliminator CP sheet 1000 rated problems. The problem name is Raspberries. So let's get started. Let's start by reading the problem statement first. We are given an array of integers and a number k. K lies between 2 to 5. In one operation you can do the following. Choose an index I and increment the number at that index in the array by 1. You need to find the minimum number of operations required to make the product of all the numbers divisible by k. So we will be given n and k and the array. So we need to output the minimum number of operations required to make the product of all the numbers divisible by k. So we are given a very small value of k. K can only lie between 3, 4 and 5. So we can directly check for all these 4 values, like how many operations would be required. So let's say we want to make our product divisible by 2. That means if it's not already divisible, that means it's an array of all the odd integers. So we just need to add 1 to the array, to any element in the array to make the product 1. So the answer for K2 can be 0 or 1. If it's already divisible, then we can have a 0. If it's not, then we'll get a 1. So now let's understand the cases for all these 3 numbers by taking an example. I will take this example for understanding purposes. 9, 5, 1, 5, 9, 5 and 1. Right. So for k is equal to 3. Let's say I want to make this array divisible by 3. I already have the numbers divisible by 3. Now let's suppose I don't have the numbers, those numbers. I have 5, 1, 5, 5 and 1. So the number of operations that I need to make this 5 divisible by 3 is 1. I will increment the 5 to 1 and I will get a 6 that is divisible by 3. For this 1 I need to have 2 operations. For this 5 I again need 1 operation. For this 5 again I need 1 and this 1 I need 2. So my answer for k is equal to 3 would be the minimum of these. That is 1. Now coming on to k is equal to 4. Now let's take the original array. Now if we apply the same approach here, let's apply the same approach here and see. In order to make 9, the nearest possible divisible number would be 12. So we need to apply 3 operations here. Similarly for 5 we need to apply 3 operations. For 1 also we need 3. For 5 also we need 3 operations. 9 again we need 3 operations. 5 again we need 3 operations and 1 again we need 3 operations. So the minimum of these would be 3. However, we can get a better answer. Like 4 can be broken down into 2 into 2. So we need to make 2 2s. So our minimum would be 2. Right? Simply saying for k is equal to 2 and 4. For 2 we can have just 1 minus even. That will be our answer. 1 minus the number of even digits. For 4 it will be 2 minus the even number of digits that we have. If we have 1 even digit, we can just increment 1 number and make it 2 even number. That will do our operations. For k is equal to 3 and 5. Those are the only operations left. We will have to take the minimum from the changed modified array. Now what is this modified array? This would have k minus arr of I percentage k. These are basically the number of operations required to make that particular number divisible by k. Like for 9, how did I write 3? I basically took the nearest possible digit and subtracted 9 from that. But this also can be done like 9 minus, we have 4 there. So 4 minus 9 percentage 4. That is 4 minus 3. 4 minus 1, that is 3. Right? That's how I wrote 3 here. So we can just make a modified using this, and the minimum of those all elements would be our answer for the cases when k is 3 or 5. When the case is 2 or 4, we can simply have this. So k can only have 4 values. So we have discussed all the 4 cases. Now let's move on to see a little bit of code. We will have an input that is n comma k. We will have an input array arr of 10. Now while taking the input, we will count the number of evens. Now if k is 2, our answer would be maximum of 2, maximum of 0, 1 minus even. Why did I take this max with 0? Because this number of evens can be 2, 3, 4. We can have any number of evens in the array. So if the number of evens is greater than 1, then we just don't need to print anything. Like we don't need to have any operation. So we'll have a max with 0. Similarly, if k is 4, we will have again a max with 0, 2 minus evens. Why the 0? Again the same explanation, and 2 minus evens I explained it here. Now the remaining cases are k is 3 or 5. So we will make the modified array. We will just modify our array. So arr of I would be k minus ARR of I percentage k. So we will have a minimum operations variable that we will initialize to k initially, and we will take the minimum with this ARR of I for each operation, and in the end we will just print the minimum operations. That's all that we need to do in this code. Now let's move on to code the same. So I have my boilerplate code here. We'll be given an n and a k. We will take both of them as input. Now we will make a vector array. Vector, that would be our numbers. We will take the input. While taking the input, we will have a count of events that is initially 0. Now if the number is divisible by 2, then we will increment our count of events. Now we will have the cases. If k is equal to 2, then we will simply print out the maximum of 0, 1 minus count of events, and a new line and a continue. Now if k equals 4, then also we'll be doing the same thing. We'll just copy this and we will paste it here. So instead of 1, it will be 2. Now these are the cases where k is 3 or 5. So now we will have a minimum operations variable that is set to k. Now we'll iterate over the array and we'll have the operations required as k minus ARR of I percentage k. I explained this logic in my explanation. Now the minimum operations would be minimum of that number and the operations required. So in the end we will just print the minimum operations for this. That's all we need to do in this code. Now let's try out the sample test cases. Give the input and I will give the output as well. I will run. So it failed on the 4th test case. Let's see what's the 4th test case. 1, 2, 3 and 4. Okay, so it is the variable is present or not. So we forgot that if the variable itself is present. So we will just take a modulo with this. Why this? Let's go back to the board again to understand why did I do that. So while I was writing this, now let's suppose for 5 and k is 5. This would give 5 minus 5 percentage 5. That is 5 minus 0. That is 5. So the number of operations required for 5 to make it divisible by 5 are 5. But that is not the case. So we will again have a modulus percentage k with this in order to get rid of this test case in which we have the element present in the array. So we'll do that in our code. So now let's try on. Again failed. Let's see where did it fail. Okay, so it failed for this test case in which we forgot that even for the 4 we don't need 2 evens, like we can make the 4 as well. So for 4 also we will do the same thing here, like making the 4. We will just take it out and or 4. So in the end, if k is 4, then we can have our operations as minimum of that number and the maximum of the above number, like this one. We can either make a 4 itself or we can make it by using 2 evens. That is the case we missed. So now let's try it out. Now it passed all the sample test cases. So now let's try to submit it. Paste and submit. And it got accepted. That means our solution and our approach is correct. I hope you understood the problem. Comment down what was your approach for solving the same problem. The solution link would be in the description section. Do check it out. Also, this is a playlist for all the problems in the CP sheet. Do check out all the other problems as well. Like the video, subscribe to the channel and share it with your friends. Thank you.